McDermott keus and performance shafts are some of the most recognized products in the billiard industry. Since the company's founding by Jim McDermott in 1975, McDermott keus have been renowned for their quality construction, exotic woods, intricate inlays, and limitless customization options. Since our founding, we've worked tirelessly to refine our manufacturing process to ensure that every cue we make is straight, beautiful, and performs at its very best. We're proud of not only the product we make, but also the efficient, low-waste cellular manufacturing process we've created. We want you to understand the process too, as no McDermott cue can be fully appreciated without knowing the people, materials, and process behind it. McDermott keus are built in a modern, climate-controlled factory located in Menominee Falls, Wisconsin. The climate-controlled environment prevents swings in temperatures from affecting the wood. Before we start our tour of the manufacturing process, it's helpful to know a bit about the terminology. The majority of our keus are two-piece keus. That means the shaft and butt are separate pieces. We'll begin by showing how the butt section is made. Most McDermott keus use a tri-core butt construction. The butt is comprised of the sleeve, the handle, and the forearm. No matter which species of wood a cue uses, we currently have 16 to choose from, you can be certain that it's a fine piece. Our woods come from vendors that we have close relationships with and are seasoned and aged to our desired specifications. Having selected a blank, centering points are drilled into it, one on each side. The blank is then inserted into our specialized lathe, where it is turned down into a rough dowel. We refer to this area as the butt cell. The dowel is sent through 3 passes. First, a very rough pass. After that, a second and third pass. These multiple turnings result in a more stable piece of wood that helps resist warping. The length of this dowel is determined by which section of the tri-core butt it will be used for. Remember, our tri-core butt construction features a forearm, handle, and sleeve. The first section we'll start with is the forearm. The dowel is placed into our computer numerical control, or CNC lathe. These machines provide the ultimate in accuracy and consistency. Tolerances are held to within 1/1000th of an inch. This time, only one end of the dowel is drilled into. The hole is then threaded to later accept the steel assembly pin that connects the forearm to the handle. From the forearm, we move on to the handle. Similar to the forearm process, we send the dowel through a CNC lathe to create the handle. First, the top tenon is created. This will be used to assemble the forearm. The dowel is then rotated by hand, so the bottom tenon can be cut for the sleeve assembly and a weight bolt chamber. We now move on to the sleeve. The dowel is placed on a lathe where it gets bored out. Once the dowel has been bored out, we cut it to length. We also use this machine to cut our decorative rings. With all 3 of our tri-core butt sections machined, we are now ready for assembly. All of the rings are laid out in sequence. The sleeve rings are slid onto the tenon, with a layer of glue between each. Then the sleeve is glued on. Followed by the butt plate with a weight bolt. The inserted weight bolt anchors all of the sleeve components tightly for structural integrity. The same process is used to install the wrap rings above the handle. An assembly bolt is screwed and glued into the tenon, which allows for the joining of the forearm to the handle. It then gets screwed in tightly into the assembly bolt. Our assembled tri-core butt is then set aside to allow the glue to dry. Once the glue is cured, the assembled tri-core butt goes through 2 passes on a router. Using multiple passes rather than just one results in a straighter queue. The first pass cuts off excess wood, rings, and glue. The second pass helps form the taper of the queue. After the second pass, the butt is cut to length. Next, the butt goes back into our CNC programmed lathe. A multi-spindle tool is used to face, drill, and tap a hole. This is where the joint pin will be installed. The joint collar tenon is machined. It is programmed for the proper joint collar style and length for the queue. A thread is then cut into the tenon. This will be used to attach the joint collar. After being discharged from the CNC lathe, the queue is returned to the assembly area, where the joint rings are glued on. Then the joint collar is glued and screwed in. And lastly, the joint pin is glued and screwed to finish off the tri-core butt assembly. After all of this, the assembled butt gets set aside again to let the glue dry. Queues that require inlay work are transferred from storage and placed in our 4-axis milling lathe, where pockets are cut for inlays to be inserted. Inlays are also cut out from the desired material or wood using the same lathe. Making our inlays in inlay pockets this way ensures a perfect fit with no gaps. Both are precision milled to a tolerance of just 1/1000th of an inch. Once cut, the inlays are placed and glued into pockets by hand. To make sure all inlays are placed correctly, the worker can view the queue specifications and images thanks to a tablet at their station. Some of our queues have very simple inlay designs, while others are much more ornate. Once all of the inlays are glued in, a line is wrapped around the queue to keep pressure on the inlays. This keeps them firmly in place while the glue dries. Once again, the butt is set aside so the glue can cure. As the butt rests, let's look at how the shaft of the queue is made. This queue, like the majority of the queues we sell, is getting a G-core shaft. It starts out as a premium maple dowel. The worker thoroughly checks the grain of the dowel to ensure that it's up to our standards. If it is, the end with the tightest and straightest grain will become the tip of the shaft. Once the dowel has been inspected, the centering holes are marked and drilled. The shaft is then loaded into our shaft-turning CNC machine. This machine makes 4 total passes. The first 2 passes cut a very rough taper. Then, the shaft is set aside for a week before getting 2 more passes. After being thoroughly inspected again, the shaft is loaded into the bar feeder. The bar feeder sends the shaft into its CNC lathe center, where both ends are machined. The tip end is machined first. For shafts like our G-core shown here, a hole is drilled for the carbon fiber rod. The shaft is passed to the other side, where the joint end is machined. A hole is drilled and tapped for a 3/8 by 10 joint. And an external threaded tenon for the joint collar is created. The shaft is then sent over to an assembly station, where the joint rings are glued and installed. Followed by the joint collar. On the other end of the shaft, a carbon fiber rod is installed. This helps to strengthen and lighten the end of the shaft for better performance. The ferrule is then installed, followed by the tip. The shaft is then banded. Banding keeps pressure on the tip and ferrule to prevent gaps. Shafts are kept banded for approximately 24 hours. After removing the bands, the shaft is stored in a Kanban storage rack for a minimum of 1 week. Now, let's check in on the butt. The butt is sent to the CNC turning center, where it goes through a final turn before being paired up with its shaft. This process cuts away the inlay material and applies the appropriate taper. The shaft is custom fitted and matched to the butt. The full queue is then belt sanded from the base of the shaft down to the butt plate to remove machine marks from final turning. After sanding, the queue is sprayed with compressed air to remove any residual dust. Then the queue is stained. Every McDermott queue that receives stain is done so by hand. Now, our famous Clover USA logo is heat stamped onto the butt plate. The G-Core logo is also stamped onto the shaft using the same method as our Clover, before sending the queue through our ultraviolet electrostatic spray booth. The spray booth applies 5 even, consistent coats of automotive-grade polyurethane. The polyurethane is applied electrostatically. Positive and negative electrical charges attract. There is a positive charge on the queue and a negative charge on the sprayed polyurethane. The spray is thus attracted to the queue. As it's being sprayed, the queue rotates to ensure a uniform application. The queue is hand sanded, then sprayed with compressed air between coats. Then it is finished with a final high luster sealer coat. This process results in an incredibly durable, not to mention beautiful, long-lasting finish. The queue is carefully inspected before continuing with the queue making process. The worker looks for issues like orange peel, fisheye, and dust. Now the queue is cut apart at the joint. The cut is chamfered to prevent the finish from chipping and cracking. This cut is very important as it provides a built-in stress relief. Pool queues flex at the joint when in use. Without the chamfer, this flexing can chip or crack the finish. If the queue has a wrap, a recessed groove is cut and tapered into the handle to accommodate it. Our no-wrap queues skip this step. Customers have the choice between genuine Irish linen, leather, or no-wrap handles. Which wrap the customer chooses comes down to preference. Most customers choose our pressed and polished Irish linen. Irish linen is a good choice, as it absorbs moisture from your hands to give you a comfortable grip on the queue handle. As the lathe spins, tension is applied to the linen to ensure the wrap is installed tightly. The worker uses a hand tool to even out linen spacing and eliminate gaps. Starch and press are used to compress linen through heat and friction, resulting in a smooth, uniform finish. Leather wrap installation starts with applying a special glue to the underside of a pre-cut leather piece. The leather is then laid down and pressed into the recessed section of the queue handle. Any overlap is cut to length with the help of a sharp razor knife before being seamed together. Now, the ferrule and tip of the shaft are turned down to the customer's desired size. Then the tip is shaped. Once that's done, the shaft is cut in our turning CNC machine to the correct diameter and taper. The shafts will get up to 3 passes to ensure straightness. The shaft is then belt sanded to remove machine marks from the shaft turning process. After belt sanding, the shaft is hand sanded on a lathe. Then it is sealed, waxed, and buffed. This allows the shaft to glide smoothly through the player's hand. With the queue assembled, we sand and polish the joint to ensure a flush fit between the butt and shaft. Due to this process, we recommend sending your queue to us when ordering a new shaft. We roll test the full queue to verify the queue rolls true and straight. Any adjustments needed to ensure proper joint alignment are addressed. Once the queue passes the roll test, the queue is ready for its final touches. Name engravings, wildfire 3D laser engraving, and customer-submitted artwork are all done in-house with our laser engraving machine. Stain or paint is applied over the engraved areas to add contrast to the design. Personalized engraving can be added to the butt plate using a variety of fonts. Final weight bolt adjustment is performed to make sure the queue matches the customer's requested weight. Lastly, the bumper is added to protect the bottom of the queue. We hope you enjoyed this behind-the-scenes look at how a McDermott queue is made. Our process has been honed to perfection since 1975, and we trust it so much that each McDermott queue comes with a lifetime warranty and comprehensive maintenance plan to protect your investment.